Great to see you here again. This is a new presentation by the Custer Academy. We are looking in this presentation to tools for risk identification. What are the tools and techniques that we can use for risk identification? We'll look at brainstorming and the affinity diagram. There is some risk identification and classification, which is FMEA and fault tree analysis. We also have interviews, root cause analysis, and SWOT. And to finish this presentation, we have a look at PESTLE, TCOP, and VUCA. I will explain these abbreviations when we come to the slides. When we look at tools and techniques, we look at some different elements that we can consider. One of the elements that's always important when we are identifying risk or when we are working on certain processes, it's in fact expert judgment. You try to get some people who are experts, subject matter experts in this area, and people who have experience with similar projects or similar business. There are different ways of data gathering. We look at brainstorming, checklists, and interviews. We look at those later. I just want to mention the checklists here. Once you go through different projects and you have more experience about the projects themselves, you may start making checklists of risks that are in fact common. And once you know that these risks have been occurring before, you can of course verify in the list, adjust the list whenever you find new risks. Data analysis, we call, for example, root cause analysis, or also RCA, assumption and constraint analysis, SWOT analysis, document analysis, different analysis techniques that may happen that you're also using in other projects or in other areas of the business. Of course, we have interpersonal and team skills. We have to facilitate how the people share information and participate in those meetings in an optimal way. We have prompt lists with specific categories. We have the PESTLE there, the TCOP or the VUCA that is quite new, the VUCA. And we also have meetings, how we can evaluate and identify the risks. We can also organize workshops which, when it is necessary. It is very clear when you look at all those tools and techniques, we have to adjust them to the size and the complexity of the project. When the project is simple, we don't have to do all these things. We may have a limited application of these tools and techniques, but once we have very complex projects, it may be important to go through these in detail. The first one I wanted to talk about is brainstorming and the affinity diagram. We're thinking about certain elements. You see the famous statue of Rodin, the thinker, and we're thinking what are the different elements that we have. So we have a list of post-its that we can use, and those post-its in fact gather ideas, things that we think about, why there is a risk, what could be a risk. And once we have a list of possible risks, we can classify and order the ideas. So basically we're putting all those ideas in different categories. And what's the advantage of this? It's basically that we can find root causes, that we can find similarities between the causes of the risks. So basically we can find out, are there risks that occur with the same cause? So by eliminating one cause, we can in fact eliminate a larger number of risks. Well, brainstorming and the affinity diagram, it's a very good technique to share with the people, to talk about a project. One idea brings the other, and finally you can classify them and group them so it will be easier to take measures against the negative risks, the threats, and to find ways to enhance the positive risks or opportunities. A very interesting element is in fact what we call the failure mode and effect analysis, or FMEA. It's a technique that was already developed in the 1940s by the military, but at the picture you see a car which was quite famous, or I should say infamous. It was the Ford Pinto, and the Ford Pinto was characterized by a failure related to the rear gas tank. Now, basically what happened, even with a minor crash, the Pinto would start to burn and people would get killed or hurt a lot. Ford was looking into this. They made some calculations and they made a very bad decision, because they calculated that paying the victims of this problem would be cheaper than remediating the issue itself. Of course, that gives a lot of negative publicity, and Ford changed, of course, their attitude toward this. Today, we also see that companies, when they find a failure, they're calling back the cars to repair the cars that are still driving, that don't have the failure yet, just to be sure that the failure would not happen there. Now, we have basically three parameters in the FMEA method. We have severity, occurrence, and detection. Now, what is detection about? Detection refers to how easy is it to detect the error. And errors that are very difficult to detect have a higher value, are more important, more dangerous than errors we can detect easily. Severity is basically the impact, and the occurrence is the probability of the risk. Now, we call the RPN the product of severity, occurrence, and detection. Now, that's the RPN value that we can calculate, and of course, the higher the RPN value, the higher on the list the risk is. But it's not as simple as that. First, we look at the highest severity. We look at severities which have a value 9 or 10. So basically, we're trying to find out which are the elements, which are the failures that will have the worst effect. We look at those, we put them at the first category to consider. The second element is the criticality. So it's the severity times occurrence. It gives us a value also. We can calculate what is the severity of the element that we are considering and what is the occurrence. So this is valid for severities less than 9, and we have to look at what's the probability of their occurrence. So basically that's the second step that we do. And then we look at the RPN, we look at the highest RPN, and based on the highest RPN, so the next of the list will be the failures with the highest RPN values. Another element looking at risk is what we call a fault tree analysis. And a fault tree analysis is basically a method which is based on a fault tree. It was developed by Bell Labs in the 60s. Bell Labs was part of IBM and AT&T. Basically AT&T, later we became part of AT&T when I was working for IBM. Bell Labs was very important, very advanced in finding solutions, and they also found a way to look at faults. Now, the element is based on logic gates, AND and OR gates, or NOR gates and NAND gates, as you see in the drawing. And an OR gate means the system will work with at least one of the elements that is okay. And we also look at the AND gates. The system will work only when both of the inputs are good. Now, basically on the top you find the undesired event. What can go wrong with system A? And basically we create a tree from the top with those AND and OR gates and NAND and NOR gates. Every element has a probability of failure, and we combine it with logical gates. The thing that we get out of this evaluation is that we find the mean time between failure, the MTBF. So basically, when you develop something, you can find in your project, you have to identify what is the mean time between failure for a certain element or system or product that you are in fact developing. So you have to understand, how does the fault tree work to find the optimal solution to adjust the system or the product to obtain the acceptable mean time between failure. For example, elements of airplanes, for example, the navigation system, they are expressed, or the lifespan is expressed as the mean time between failure. Basically, it tells us that an element can be operating for a certain number of hours without having a failure. Now, that's a theoretical approach. It can be less, it can be more, but that's what we expect. In reality, once you have those elements designed, you will find out what's the actual time between failures. So you are evaluating the time between failure, and then you have also the mean time to repair to understand how long a system will be available and not available for the airplane, for example. So basically, it's quite a complex way to find out the mean time between failure. We have failure rates of different components, for example, resistors. We know that in certain conditions there is a probability that it will fail after a certain time, and we put all these elements together in a complex system, and the fault tree allows us to find the combined probability of failure, or the mean time between failure of that composed element. A very interesting item or element is to look at interviews, and when we look at interviews, we have to look at who do we want to interview. We also have to identify the relevant questions. We have to ask if the experts are really experts in this matter, and you also have to challenge the results that you receive. We have to find people who are close to the issue, and we also have to identify the value of the information that we get. Now, one of the things what I learned doing interviews is that you have to challenge the opponents. People who are negative about the solution that you are proposing may give you more elements, more valuable elements than people who are supporters. People who are supporters are already, in fact, in favor of what you want to do, and they may not see the threats, but they can provide opportunities. So opponents typically give a better overview, a better feedback than supporters, but both, of course, are valuable, and you have to identify, am I dealing with an opponent or am I dealing with a supporter? Another element what exists, or a method that exists, is root cause analysis and 5 times why. Now, the goal is to find the real reason behind the risk. Now, for root cause analysis, we have a 7-step system. First of all, we have to define the issue or the risk that we want to consider. We have to gather data and evidence or evidence. We have to ask why is this happening, to identify causal relationships. We identify the causes to be removed to remediate. We identify solutions to prevent reoccurrence. We implement the recommendations, and we observe to ensure effectiveness. And of course, we will repeat this until we reach the level of certainty that we want to have. Kaizen also has a very interesting method. It's called 5 times why. And typically we ask why. Why is something happening? Why is, for example, the engine breaking down? Oh, the engine is breaking down because the oil filter stops working. The next question is, why does the oil filter stop working? Oh, we find out that although we replace it on time, there may be some different way. There is more dirt coming into the oil than what we expect. Why is there more dirt in the oil than we expect? And we continue and we go on until we find, in fact, the basic reason why something is not working properly. You can do this, but be careful. If you keep on asking why too many times, people may be angry, but it's a very good method to identify the root cause of a problem. You also know the SWOT analysis. You've seen that in business cases. We look at strengths, typically internal. Strengths and weaknesses are both internal parameters. Strengths are helpful, weaknesses are harmful. So we have to find out what are the internal positive elements that we have, what are our strengths, but also what are our weaknesses, because we have to understand where are we weak and what can we do about it. The other things that we can look are external opportunities. Opportunities typically external elements, helpful elements, and the threats. So strengths, weaknesses, opportunities, and threats is a very interesting analysis. We also find it in business cases, and you can apply it, of course, in your project. Another analysis which is also very popular is the PESTLE analysis. We have the parameters political, economic, social, technology-related, legal, and environment. And basically, political relates to competition, policies, industry, things like that. Economic relates to economic parameters like interest rates, consumer spending, income, exchange rates, GDP. Social relates to social environment like demography, demographic shifts, impact of pressure groups, and so on. Technology relates to technological changes like disruptive technologies, adoption of mobile technologies, new production processes, big data, and dynamic pricing. Legal relate to employment law, minimum and living wages, health and safety laws, environmental legislation, impact of the European laws. Environmental, typically sustainability, tax practices related to ecology, ethical sourcing, and pollution and climate policy. PESTLE can also be used in some business case evaluations and in some business evaluations that you are looking or considering within your company before you define project. Another analysis type is the take-up. We call this a technical, economic, cultural, organizational, political evaluation, but we can also have an alternative description. It can be technological, ecological, commercial, operational, and political. So there are two ways to look at it. Technical, we look at information and communication technology, R&D, equipment and machinery. Economic, financial management system, cash flow, reserves, commercial viability of the organization. Cultural means demographic, collective attitudes and behavior of the organization. Organizational factors include capabilities, policies, standards, guidelines, strategies, management, structures, and objectives. And political factors include governance, internal politics, decision-making systems, stakeholder roles, and accountabilities. So these are also quite interesting ways to consider or to evaluate risk on your project. A more modern approach is what we call the VUCA analysis. VUCA refers to volatility, uncertainty, complexity, and ambiguity. Typically, we were looking in the past at stable environments, but we've seen in the recent past, COVID, climate, all kinds of other problems that we have. It's in fact that we have to look at a more, let's say, unstable environment. And VUCA brings ways to analyze these unstable environments. Now, when we look at the VUCA world, we have to build resilience in the system. We have to have reserve resources that can be deployed when necessary. Identify clearly what you want to accomplish. We have to have innovation and improvisation mindset. We have to go get the backup ready in case you need it. For example, a VUCA world is typically a military world where people, when you are in operations, something can happen. Everybody has an XO, and second in command, who basically can take over when something happens with the commander-in-chief. And it happens sometimes. In Mali, there was the battalion of the Foreign Legion which jumped on Mali, and the first casualty of that day of the operation was the commanding officer of the unit. In that moment, you have the XO, the second in command, who has to take over command of the unit and assume different responsibilities than what he or she would normally do. So that's an overview of those tools and techniques related to risk. And we have to consider all those elements when we are looking into risk management. So that was it for this presentation. Thank you very much, and I'm looking forward in our next video. Bye-bye.